Good morning and most welcome to 1393 of the Heidegger series. Today we're going to take up some of the foundational quantum mechanics as propounded by Allan Emrén and explain with contrafactual science, put it under the specific microscope of contrafactuality and see what understanding that will give. So I will go through some pointers written by Allan Emrén to my colleague Chiara Marletto that points to certain foundational traits in quantum physics. We have the observer or reader who determines if the cat is dead or alive upon observation of the subject. Comment from Emrén. The observer does not determine whether the cat is dead or alive. The observation forces the universe to make a decision, to decide if the cat is dead or alive. This is most definitely one of those pinnacle questions. Allan is here making a distinction between observer and the act of observation. It is not the observer as an object, but the doing in the depth and act a verbal thing. The doing. It's an activity. And that will collapse the quantum probability wave function of Schrödinger. This is specifically treated in Chiara Marletto's book. In the third chapter, page 76, called Information. It is the clearest explanation of observation I ever read. And it is in an oddly clear and common sense language. And I will try to put extra stress on the first question, because it does actually determine all the other comments. It has to do with what is information. And there are two varieties here. Is information what we normally think of information? A string of facts can be consumed or taken in, grasped, if you like. The second alternative is more quantum mechanical. My term is information as an ongoing process of doings. An activity, if you like. The first option is how we always see information. A string of words, numbers, or definitions. The second one is the completely different quantum mechanical understanding. I will read a few pages from the beginning and then take a discussion together with a summary. Information. Where I explain how information can be completely captured within physics with two contrafactuals. The possibility of copying and flipping, where you encounter the counterfactual property of universality and learn how it enables universal computers. When the night falls on Sentosa, a small satellite island of Singapore, a remarkable spectacle takes place. The best location to witness it is somewhere along the bridge connecting Sentosa to Singapore. That bridge is made of smooth wooden tiles. It also has a panoramic spot where one can rest, leaning on a balustrade. While enjoying the view that spans the whole bay. As the twilight turns into night, distinctive kinds of lights and sounds fill the air. The surroundings gradually become darker and darker until the whole backdrop is pitch black. Both the sky and the sea at that point, the spectacle reaches its peak. Suspended several dozen meters above the sea, green-lit cable cars run smoothly through the air, back and forth. In constant, gentle motion. Boats and ships move lazily across the bay. Their signaling lights cutting through the darkness. The music from the bars on the shore spreads around, whispering in the warm equatorial night. Farther back in the distance, a lighthouse flashes on and off, on and off. The last one is of pertinence. I will repeat the last part of that sentence. A lighthouse flashes on and off, on and off. The objects populating that nocturnal landscape display extremely diverse behaviors. Each explained by a different branch of physics. Cable cars, boats and ships are powered by engines. Explained by laws of thermodynamics. Music and its propagation are explained by the theory of sound. Sound is composed of waves of molecules of air. Which travel to one's ears and are then converted into electrochemical signals in the brain. Molecules are in turn composed of atoms. And atoms are made of subatomic particles such as protons, electrons, and neutrons. Light is explained by the laws of electromagnetism. Maxwell's equations. At the most fundamental level, all those phenomena are explained by quantum theory and general relativity. The two deepest explanations of physical reality we possess at the present. My commentaries do note all is verbally put. And remember that the process of going down from the biggest to the smallest is in itself a process. not a static. Despite being so different in the specific details, those systems have something in common. Which is not explained by any of the existing branches of physics. The music, the boat's lights, the lighthouse, they are all signals. They are capable of carrying information. This property is a key trait they all share, one that, in parenthesis and nota bene, contrary to what one might think, is possessed only by a particular class of systems in our universe. My comment here is we usually see information as being outside of us. Being like things. Individual existences, if you like. And that those existences are just out there for the take. Instead, I think of information as an active process. Involving this act of observation Emrén mentioned. It is doing, and it is an active doing. In a way, there is no need to introduce a passive, classical observer. Or why not a static consciousness? What quantum mechanics stirred away from was the two byproducts of the Newtonian paradigm. A static observer and its counterpart, a view from nowhere. In quantum mechanics, in the practical details. Doing an observation is setting up equipment in a specific intended way. It's an act. It does not happen by itself. It has an intention. It has a why. This is the act of consciousness. I will add a comment from Allan Emrén on page 8 here in the comment list sent to my colleague. The Xi function of the entire system would express this by having in it the living and the dead cat mixed or smeared out in equal parts. From Mr. Emrén. Not smeared out, not mixed. Although mutually exclusive, both exist as 100% real at the same time. This is one of the shocking features of quantum mechanics. To help with the understanding, I will once more apply the Necker cube. Both features of the Necker cube are 100% real. The act, the doing of observing the Necker cube will make the second take of the very same cube disappear. This exclusion this doing is the act of observation. Is the other part of the Necker cube not real? No. It is, as Emrén writes, 100% real. My way of seeing this is that observing is excluding, covering. The very act of exclusion is observing. doesn't mean that the Necker cube becomes imagined. The wrong question that popped into my tired brain when I read this was the automatic question. Which is more real? The Necker cube or the observing act of exclusion? That is a wrong question. They are both complementary, necessary. Although very true, mutually exclusive. Of course, what Emrén wrote, it's a shocking feature of quantum mechanics. He is there echoing the father of quantum mechanics. Niels Bohr. If you are not shocked by quantum mechanics, haven't begun to understand. I would say that that comment is necessary for the understanding of quantum mechanics. You need to be shocked. It defies all common sense. But it's still what we discovered through observation.
Vad står det där? 57 minutes. Oj.
I put a little pause and I will do something on the whiteboard and we'll have some questions. So here you can see a pretty good depiction of the smeared out situation of reality. A superposition as being smeared out. And we now go to the whiteboard. And as you can see here, this is a very common depiction of the observer event. And although strictly correct, it has tendencies to be misleading, possibly even unavoidable. With the understanding that we have when we encounter this image, an idea of objectification will take place. The I will be an observer or a consciousness, and we could also think of the Necker cube or whatever is there as an object as well. But none of these two are things. They are not static. They are not only one feature, and the I is the doing, a process. So both of them are processes. You could stop the thing, I do it like this, and do a förhanden on the Necker cube, and really both the varieties are real in the Newtonian way. But, and this is maybe the most important thing, the process comes before, and what happens, the things are derived, secondary, not foundational. And they are most definitely mutually exclusive. When there is one, the other cannot be. And this is the shocking thing with quantum mechanics. And this is why I said, if you don't get shocked, you haven't started to understand. It defies all logic, all normal ways of understanding. And this, I would say, is the zest of the two first comments, but also of the rest. And if you have established this and trained it, understanding will come as in itself an act that progresses. Take some questions now or comments. The whiteboard is yours.
I will. Hello. I will read something from my laptop, and I will read from Schrödinger's 1935 paper, the iconic paper about the cat. So this is the last part about the cat experiment. If one has left this entire system for 1 hour, one would say that the cat still lives. If, meanwhile, no atom has decayed, the first atomic decay would have poisoned it. The psi function of the entire system would express this by having in it the living and the dead cat mixed or smeared out in equal parts. So this is a direct quotation from Schrödinger that both Allan and Hans criticizes. And since this last phrase is so important, I will also read it in its German original. Die Psi-Funktion des ganzen Systems würde das zum Ausdruck bringen, dass in ihr die lebende und die tote Katze zu gleichen Teilen gemischt oder verschmiert sind. So the problem for me is that who is right? Schrödinger, who affirms that the cat is mixed or smeared out in equal parts, or is Allan right? That is they are, so to say, mutually exclusive. So Allan writes, to repeat his words, not smeared out and not mixed. Although mutually exclusive both exist as 100% real at the same time, This is one of the shocking features of quantum mechanics. So could it be that both Schrödinger and Allan are correct? Like take this tray with this peanut butter that I unfortunately made out, the peanut butter. To compare it with the cat analogy, the psi function of the entire system would express this by having the living dead cat. So this peanut butter symbolizes the cat, which is both dead and living, and is mixed and is made in equal parts. So what he's so it's entangled. In Schrödinger, I would say that the living and the dead cat, you have how would I express it? So that let's say that you could have a little bit butter here as well. So the butter could symbolize, say, the living cat, and the peanut butter is the dead cat, or vice versa. So it's made out, or it's the psi function that is made out, so to say. Now it's the cat itself that is mixed or made out in equal parts, while Allah wants these two things completely separate, that they don't have, so it's two separate categories, so to say, dead cat or the living cat. But I would say that my humble proposal is that both are right, that Schrödinger is correct, that it's like this stray peanut butter that you have, the cat is mixed out, but at the same time they could be also completely separate in two different categories, as Allan wants it. What is your opinion, Hans, about this?
Why, thank you very much, Kalle, for that comment. I agree. I think both Emrén and Schrödinger are right as well. I would not go so far as to say that it is a question of how you express yourself or semantics. But yeah, it is the view of Schrödinger and Emrén are to a great extent exclusive in themselves, actually. So the double take of reality is also in the descriptions of reality. They are themselves ambiguous. My personal view is that this very ambiguity is what makes expressions and reality a process and real. Although I do agree also, it is definitely a shocking feature. No comment, or we continue?
Hans, thank you. I'm happy that you more or less agree with me. I think each one hand is very useful for educational purposes to separate things in categories, like Allan makes that only dead or living to the separate categories, and that they are not mixed with each other, and they are also dead or alive at the same time. But as we have learned from Derrida, there is always a trace of something in the other. You cannot completely put so to say a divided line. So I would prefer Schrödinger himself because it also fits with the great idea of the Nobel Prize in physics of the last year, that is entanglement. If something is like mixed, which are smeared or mixed, so it means that nothing is completely separate from each other. How can death be completely separate from the living thing? And it was interesting. I read unpublished lecture series by Derrida in 1975 that he took up this thing. and I allowed these ambiguities homonyms and to make an inappropriate joke perhaps if about pea butter. If I say only pea, is the cat's pea here? Very inappropriate, but everything is so entangled with each other. You cannot be categorical, because if you are very categorical, so dead is here and living is there, they are not mixed, then you very easily end up in classical physics, where everything is very is in different separate categories, like this and this. Okay, so I give it back and I apologize for my bad homonymous joke.
I also seem to be very entangled with my mobile. I was waiting for a wireless and now I am connected to the mobile. Where it goes, I go. Entanglement. I will continue for a while more and give ample time for comments at the end. If Kalle could check the spot around 45.
Yes.
Do we have now?
1 hour and 13.
Okay, another half an hour.
Yes.
I think this was a very good format for a discussion, to have a comment series as a hub for an expansion of thinking. I will go to page 10 in the text. Until you open the box and observe the animal. The cat is alive or dead, or both states at the same time, that is, alive and dead. The comment reads, the reality is more shocking than you appear to have realized. before the box is opened and observed. The cat is only alive, only dead, and both states at the same time. Perhaps this would be too difficult for the reviewers to understand. So one has to limit the difficulties, taking away part of the sentence as no or is possible, and the conclusion would then be until you open the box and observe the animal, the cat is alive and dead, both states at the same time. Excuse me, I'm just going to need to put this battery. If I don't put it back, the mobile would be dead and alive. I will illustrate this by paralleling it with contrafactuals, because they do play a role here. Continue where I left off, the second paragraph at page 78 in Chiara Marletto's book. What is the property that makes those systems and many others like them capable of carrying information? Answering this question involves counterfactuals. And it will keep us occupied in this chapter. It will reveal the way to express information as a fundamental entity in physics. And the fundamental physical laws that rule the physical system, capable of instantiating information. This is crucially important. Not only from the point of view of understanding the universe in a deeper way, but also because information and its connection with physics is at the heart of information technologies that could further revolutionize our civilization. Such as the universal quantum computer. That we will discuss in chapter 4. At first, it may seem that information does not really have anything to do with physics. In fact, in everyday language, the word information is used to refer to all sorts of things. For instance, many systems contain information. Books, newspapers, and magazines. emails and messages. The words we utter when speaking to friends and family. Poems, songs and ballads. The biosphere contains information too. Encoded in DNA molecules. But even though all those systems are plainly part of physical reality, it is hard to identify information with a particular physical system. Information looks more like an abstract entity. And it is hard to pin down its connection with physics. For a start, information does not have a specific embodiment. But it can be embodied by many diverse physical systems. Is it then some kind of property that systems have, such as, say, color? that a laser light is green, for instance, means that the photons it emits the quanta of energy it is composed of have a particular frequency or energy content. Could information be something like energy or frequency? Not quite. Those are factual properties because they are specified exclusively by the system state at a certain time and in a certain location in space. My comment here, do compare with the observational process. It is information. But when it comes to information, the story is different. As I shall explain in detail, one cannot say that some system contains information just by stating a full description of its state. And its factual properties. Because the fact that it has to do with certain transformations being possible on it then what do we mean when we say that a computer or a smartphone is carrying information? than seeking to define information as a physical entity, or as a property of physical systems, the key is to change our focus and ask a slightly different question. What is different in the state of affairs of a physical system between when it does carry information and when it doesn't? And I put a comment in here. The both real sides of the Necker cube, or the cat being both dead or alive, or either or neither, doesn't carry much information. After the exclusion, the observational act, there are much more information. End of my comment. It is, as I shall explain, a set of counterfactual properties. Once we pin those down, we will have established what is required of a system in order for it to contain information. And the connection between information and physics, without ever actually having to define information directly. A short comment, sorry about my many comments. But think of the both factual properties of the Necker cube being counter to each other, as well as the cat or a mouse, if you like. Let's use a thought experiment to identify the counterfactual properties that a system must have to carry information. First, we take a system that can carry information, such as a lamp can be used to signal. Then we gradually subtract its key properties until it stops being capable of doing so. At that point, we will know that the properties we removed in our thought experiment are necessary for carrying information. Before I make a pause to do the whiteboard, and a thing appeared at this moment. My blood sugar meter beeped. And you could actually say, I ignored it because it didn't show up contrafactual features. There were no either or. I had the information, and thereby the device did not carry information. It had stopped to be counterfactual or dead or alive. It showed high because I just ate. So it is the counterfactual state of being two opposing things that can give information. In the case of the blood sugar meter, it was high or low, but the psi had already collapsed, and therefore it could no longer give information. It had only one state. Pause there. In the penultimate lecture, we looked at the paradox of Zenon, and he takes the path from initial conditions to terminus, the goal, to be of mutual exclusive character. When the hare or the tortoise is in a certain spot, that location according to Xenon excludes all other locations. Therefore, there is no contrafactual, and the system carries no information. There can be no observation as a movement, as well as there can be no movement between initial condition and terminus. And the odd conclusion was for millennia that the hare, the rabbit, or what you like, will never catch up with the tortoise. And maybe you see the parallel between information and movement. In the mutually exclusive, non-contrafactual, neither movement nor information exists. Hence, there is no observation. Once contrafactuals are introduced and we have observation, the hare will be observed to win, to catch up with the tortoise. This, I mean, is a feature of both Xeno or the Newtonian paradigm. A still way of looking at a world without information nor movement. One view here, of course, of Xeno is he determines that without a doubt the hare is here. It's almost a homonym. This localization is parallel to the coordinate system in the Cartesian stillness. where time nor movement is possible. Everything is constantly collapsed already, irredeemably. The paradoxical character will introduce movement and information, and the living, active, temporal observation. This is the life of time. This is constant happening. Maybe some comments here from my dear colleague. I'll help you with that thingy.
Greek you had an extra n, but in Latin say only zero. But anyhow, so I was thinking about, let's say that we had a cat instead here running, who against a turtle, to make a comparison to the Schrödinger's thought experiment about the cat. And then here you have the terminus, and I like in this case terminus could work because it's both the goal, but it can also stand for death. Like remember we discussed the Greek word telos, which is both the goal and the end. So the goal and the end is the same thing. But my point is that when you run, like in a race, you have a straight, you have to cross a, what do you call it in English, this strap, and but where is really the goal? Where exactly is the where did you arrive at the goal? So it's a very is it when you touch the ribbon here, or you go over 1 centimeter of your body? So it's a borderline. So I would say that also in these cases, where is the dividend line between the goal and still here in the race? So it's so easy to put things in categories. So it's easy to get stuck in this. While I would say that there is trace, like Derrida would say, perhaps there is trace of the race here and here. They are all entangled. The goal, which is also the end, so to say. Something like that. So we don't have mutually exclusive states ever, I would say, contrary to Allan. But again, it's interesting that now, 1975, Derrida gave out lectures about death and life, and they are now being published. 2019 they were published in English translation, so I hope that you, Hans, could ask the library to buy in this. 2019 was finally, after so many years, they were published. And in 2018 there was published something else, namely Bio-Deconstruction, a book that UB brought to us. And we should go through that, because there Derrida deconstructs the division between life and death. And it's by two Italian scholars, Senatore and Vitale. We should go through that so we don't get stuck in this artificial borderline between death and life. Because when you're dying, for instance, where is the borderline between death and life? Who will go there? Now you are dead, but you're still perhaps breathing a little bit. So it's very difficult. It's so Newtonian actually to say now you are dead, because we have also this not very people have waken up after death, so to say also, and it was fun. I watched an exorcism on Sicily, the city of Palermo. And he went to a dead man, and this was witnessed by many, and he asked him to wake up. He woke him up, he resurrected him, so that he could say his last confession, and then he died again. Very funny, but witnessed by many. Thank you.
Yes, indeed. The line here would also be very, very sharp in the idea of Zeno or the Newtonian paradigm. And I would say that's a sharpness that is mistaken. There is no sharpness without the ongoing movement. Blurry on the both side, end and start are codependent as well as contrafactual, and as indicated by the great Greek philosopher Heraclitus, death and life are of similar nature, yet exclusively to each other.
Dionysus and Hades are the one and the same.
Very good.
Thank you.
Thank you for your patience and have a very pleasant afternoon. Bye bye.